The title of these notes is Function Operations. Make sure that you've put your name, date, and class period in the top right corner. And the outcome for these notes is that you'll be able to analyze the domain of the sum, difference, product, or quotient of two functions. Those are your four basic operations: adding, subtracting, multiplying, and dividing. So before we actually talk about how to add, subtract, multiply, divide, we're first going to talk about the domain of a function. So as a refresher, your domain is all of your possible inputs. So we have some basic functions. Those are called parent functions. And one of our basic functions is the linear function. That's y equals x. Looks like that. Straight line. Any number can go into this function, so we say that its domain is all real numbers. You might have abbreviated that all real numbers, ARN, in the past. In Algebra 1, you also learned about quadratic functions. Those look like y equals x squared. And you can square any number, so the domain is also all real numbers. You also may have seen exponential functions. Those look like y equals some number. I'm going to call it b to the x power, where b is some number. Those functions look like that. Again, you can put any number into the exponential function, so its domain is also all real numbers. Something that has a domain that's not all real numbers is your square root function. Y equals the square root of x. Because as you studied last year in Algebra 2, you cannot take the square root of a negative number. So that function looks like this. Notice that there's nothing to the left of the y-axis because I can't input any negative numbers. So the domain here is only values that are greater than or equal to 0. You can take the square root of 0. That's why it's equal to 0. Okay, so what we're going to be doing is we're going to be using a different notation for domain. And we're going to use something that's called interval notation. So instead of saying all real numbers, you're going to write it as an interval. Think of it like a number line. And you're going to say what's the leftmost point and what's the rightmost point. So if you're talking about all real numbers on the number line, that goes all the way left on the number line and all the way right on the number line. So the interval notation for all real numbers is going to be from negative infinity to positive infinity. All real numbers will look like from negative infinity to positive infinity. What about the square root function, where the domain was not all real numbers? It started at 0 and went to positive infinity. So if we think of this like a number line, the domain starts at the number 0. It includes 0, and then it goes to positive infinity. So the interval is from 0 to infinity. Now because it includes 0, instead of using the parentheses, we're going to use the square bracket. So the square bracket means that it includes that number. The round bracket means less than or greater than. It does not include that number. And the reason we have a round bracket around the infinity is infinity is not an actual number. You can't actually equal infinity, so I can't include infinity. Another type of function that we're going to be looking at in this unit is what's called the rational function. And we'll spend a lot more time on this. But the basic idea of the rational function is that y equals 1 divided by x. We're not going to worry so much about what that looks like, but let's think about its domain. What can you divide by, or what can you not divide by? There's only one number that we can't divide by, and that's 0. So our domain is all real numbers except 0. So if we think about what that looks like on the number line, here's 0, and I'm not going to include 0, so I'm going to have an open hole there. And I could shade everything to the left and everything to the right. I can input any number. So I actually have two intervals here. on the left side, I have everything from negative infinity, that's supposed to be infinity, to 0. And then on the right side, I have everything from 0 to infinity. I do not include 0, so I have the round brackets instead of the square brackets. You can never include positive or negative infinity. Both of these are pieces of the domain, so we need to connect them with an and symbol. In math, it's going to be what's called the union, and it looks like a capital U. That's the union, and it means and. So the domain of this function is negative infinity to 0 and 0 to infinity. Okay, so now that we have a little bit of idea about domain, let's talk about actually adding, subtracting, multiplying, and dividing functions. I'm going to cover this up so we're not looking at all of it at once. Okay, so first of all, adding functions, it is going to be as easy as it looks. You're literally just going to add the two functions together. Same thing for the difference. You will just subtract the two functions. Product, same exact thing. You're going to multiply the two functions. Quotient, you're going to divide the two functions. That part's not the hard part. What we're then going to do is we're going to analyze the domain. For the first three, the domain of your new function is the domain of f and the domain of g, and this symbol is the upside down union, means intersection. So what that means is the new domain is everywhere where the domain of f and the domain of g overlap. We're going to do an example of this shortly. The quotient function is almost the same. It's still the intersection of the two domains, just like the other two, but with an extra caveat. And that extra caveat being, remember that if we're dividing by g, you may not divide by 0. So you also have to exclude the place where g could potentially equal 0. So I'm going to do a couple examples with you, and then we'll pick this up in class. So I need a definition for f and for g. So let's call f 3x plus 2. And let's call g let's call it x minus 1. So both of these are linear functions. So their domains right now are all real numbers. The domain of f is all real numbers because it's a linear function. And the domain of g is also all real numbers because it's a linear function. Okay, so if I were to add these, f plus g, that would mean that I would just add f, which is 3x plus 2, plus g, which is x minus 1. And then I'm just doing some algebra. I'm going to combine my like terms. 3x plus x is 4x. 2 minus 1 is 1. So that's the sum. And then the domains, I'm going to look over at the domains of the original two functions. I'm going to see where they overlap. All real numbers overlaps all real numbers everywhere. So the domain here is still all real numbers. And I want you to get in the habit of writing that in interval notation. If I were to subtract these, I would have 3x plus 2 minus all of g. So I'm going to put g in parentheses. So I have 3x minus x. That's 2x. And then watch your signs carefully here. I have negative 2 minus negative 1. That is negative 1. And the domain is where the two domains overlap, just like they did for addition. So the domain is also all real numbers, from negative infinity to positive infinity. Okay, I'm going to continue likewise with product and quotient. So if I were to multiply f and g, f times g, I have 3x minus 2 times 2x minus 1. I'm going to FOIL this out, and I'm going to get 6x squared minus 3x minus 4x plus 2. Combine those like terms. And the domain, again, is where they overlap. So the domain is still all real numbers. All right, and then the last one, the only one that's a little bit different with domain is the quotient. So I'm going to do f divided by g. And so that will be 3x minus 2 divided by 2x minus 1. If I could simplify, I would, but I can't simplify either of these because there's no factors here. Here's where the domain changes just a little bit. It is where they overlap. They still overlap at all real numbers. But we have this extra caveat. Remember that we cannot divide by 0. So I want to check, when does this equal 0? So I'm just going to do a little bit of algebra. When does that equal 0? So I'm solving. And I'm going to find out that it equals 0 when x equals 1/2. So my domain is supposed to be all real numbers, but I need to exclude 1/2 because if I put 1/2 into this new function, I'm going to get a denominator of 0. So now my domain is everything except for 1/2. So again, thinking of this like a number line, the only number that is not going to get into the domain is 1/2. So I'm going to put an open circle there and then highlight. So everything from negative infinity to 1/2 is in my domain, and union symbol, everything from 1/2 to infinity is also my domain. So the domain of the quotient is this piece right here. The domain is everything from negative infinity to 1/2 and 1/2 to infinity. All right, this is the basic idea. I'm going to do one more example that's a little bit more complex, and then we'll practice this in class. So I'm going to do somewhere f and g don't already have a domain of all real numbers. So let's call f the square root of x minus 1. And let's call g the square root of x. All right, thinking back to your square root function. You cannot take the square root of a negative number. So let's think about the domains here. The domain of g, I cannot take the square root of a negative number. I can take the square root of a positive, and I can take the square root of 0. So the domain of g is everything from 0 to infinity. No negative numbers. Okay, well, what about for f? Notice that I have x minus 1 under that radical sign. So this, under the radical sign, can't go below 0. It has to stay greater than or equal to 0 because it has to be a positive number. So solving this, x has to be bigger than 1. The lowest x can be is 1 because 1 minus 1 is 0. That's the lowest I can go. So I'm going to include 1 and then all the numbers greater than 1, going all the way up to positive infinity. If I were to add these, square root of x minus 1 plus square root of x, can't simplify that anymore. So this is the sum. The domain is where the two domains overlap. So I'm going to draw these out as number lines because I think it'll help you see where they overlap. Here's my number line for f and for g. F includes 1 and everything greater than 1. G includes 0 and everything greater than 0. Where do those two domains overlap? They overlap beginning at 1. So the domain of this function is from 1 all the way to infinity because that's where these two domains overlap. You can't include from 0 to 1 because even though it's part of the domain of g, it's not part of the domain of f. All right, so as a challenge problem, let's do the quotient, f divided by g. It's going to be the square root of x minus 1 divided by the square root of x. Can't simplify that anymore. We're not even going to try. But let's talk about the domain. The domain, again, is where they overlap. And like we've just seen, this is where they overlap. That's the intersection of the two domains. But we also have to think about the denominator cannot be 0. This cannot equal 0. When does that equal 0? When does the square root of x equal 0? Well, let's solve it. Square both sides, and we get the x equals 0. So 0 cannot be in your domain. So remember, our domain is the intersection of the two, which is from -1 to 0, excuse me, from -1 to infinity, and it excludes 0. Well, the good news is this already excludes 0, so we don't need to write anything else. Already excludes 0. So the domain here is also from 1 to infinity. That's going to be it for our examples. Go ahead and draw your line for your summary and bring your notes into class.